Hello, let me give you an introduction to Lindorm SediMeter software version 6. When you open it, you get the SediMeter control window that you see here. And here, these tabs are for communicating with an instrument or a network of instruments that are connected. Right now, nothing is connected, so they don't work. Even if we don't connect to an instrument, we can still open previously recorded data. And we can open the monitor and display window. So let me open this. And here you will see that we have a number of tabs for viewing the data, a plot of the SediMeter OBS detectors, the data plot, data table, the burst samples, synoptic data, that is data recorded in real time, a false color plot of the same thing as the SediMeter plot, it's just in another way of showing it here, and a SediSond plot. So now you have an idea of the different things you can see here. Let's go back and look at the control window again and connect to an instrument. First we have to select which serial port it's connected to. Typically you will have only one and it will select automatically, but I have several here. If you have changed the baud rate in the instrument from the default 9600 bauds, you have to set it here before connecting. And we do offer on radio, but the vast majority of times it will be connection by USB cable, which actually it has a USB connection on the computer side, but on the other end there is an RS485 connector, underwater pluggable connector. So we click open connection and now it's connected. We can see here when we go to timing, it downloaded the time in the instrument here. So this is the computer time. And it's shown in UTC now, which is the value that is stored in the instrument. If you want to see it in your local time zone, just uncheck this and you get the local time here. This does not change what's in the instrument. And if you want to update the instrument time, just click set. And if you click get, you will see that now the difference in time is very small. There are 4 more things here you can set. The start time of a measurement, the interval between measurements, and then here we have the burst group. And let me get into distinguish between 3 different things here. One is the measurement interval, and the other is the burst interval and the number of burst samples. And the third is the accelerometer subsamples, which I will get back to because that's in a separate window here. You can change the accelerometer in this instrument. So for each measurement, you can do 1 or more subsamples. And this here is the interval between the subsamples, shown here as frequency in hertz. So let's say we want to start measuring. You can type in the hour, minutes here, but you can also do a quick set here. This will set it at the next full minute, and that's just about to happen. So, well, actually that next full plus about 5-10 seconds. And the interval here, let's say we use 1 minute and 1 sample. We click set. So now the instrument is programmed, but it is still not in logging mode. It's still in sleep mode. We have to change the mode. It says here as a reminder, change mode in system. System is up here. We can click here or we can click here. And here we can select any one of 5 modes. I will get into each one of these later, but for now, the basic logged mode logging mode, timed logging, is this one. And all you have to do is to select that and click set. And now when you go back here, you see instrument is armed and is coming up to measurement time, and there it took a measurement. And now we can actually go back and put it back to sleep. And we can go to download. And you see now we have one new record, one total record. And to download it, we have to select a file. I had already done that. Select a file here, or type in a name. I always save it to dummy when I'm doing testing. And then to download, you click download. And you can select here whether to download just the new data or all data. Downloaded one record, okay? And now we can watch that in the monitor and display window. Here we have the straight measurements, the oblique measurements. We click adjust and it will adjust it. And both of them. This option here, air and sun, that is for SM5 only, which has 3 channels of data. And in data plot, well, there is a spot in the middle here, 1x, because we only have one data point now, so there is no line. In data table, we get these burst samples. We get, we have to click acceleration to show it. There you go. All right, so there we have the measurement of the 3 axes, X, Y, and Z. Since it's lying down on the table, Z is 0. And we have nothing in synoptic, obviously. In the false color is not so interesting because this is SM4 and we are not doing a SediSond measurement. So, when we close this, the data we just brought here will not be sent back. So we lost those data from memory now, but we can get it back. If we want to look at it again, we go back here and we just import log file. And we can open it again. Now, you've seen how to set up a simple measurement. And if we check now, it says no new records. We already downloaded it. And it's possible to erase the memory. But I will let it be for now. Now, you've seen how to take a single measurement. But what if we want to take several in a burst? Let's say we want to take 10 samples with 3 seconds per sample, and the 3 is because the accelerometer is set up to measure at 10 Hertz 30 samples, and that takes 3 seconds. So if we do it this way, it would take 30 seconds, and let's say we put it at 2 minutes interval. The next is 45. I'll see if I can do it quickly enough. Yeah, now it should get to 45 here and start measuring. There. Now it's measuring every 3 seconds. And while it's measuring, it's actually sending us data here. We can listen to it every 3 seconds. Oh, it wants us to save it here. See here? It's coming in data now every 3 seconds and it's being saved to file. And we can see how it's coming in. We didn't start from the beginning, but we got all those, and by 12:45, so the next time is 12:46, we should get the next ones coming in. Oh, I put it on 2 minutes, of course. I turn off the log to file. So now when it reaches 1247, we start to get data coming in again every 3 seconds. And here we can see the last record. So we can actually see in real time here the accelerometer data coming in. And we can see the SediMeter data coming in. And we can see, now we're looking at all, but we can see clean time series where it only takes one from each burst, and we can look at individual bursts. This is the first one. The second one hasn't come in yet because we lost the first one. And this is a timed burst. So we see in time here, we got the 10 measurements, 47, and then every 3 seconds. So if we hang on and wait a minute and a half, we will get the next burst. I will put something here with dots on it so we can see. And we can look at the tilt, vibration. While we are looking, here in burst samples, we can see the whole burst group. These are 30 times 10 accelerometer measurements. And we can't listen to it because the frequency is too low. Even if we raise it, I think it will, it's too low. We have to have a higher accelerometer sampling rate in order to listen to the data. Now we are getting new data here. And now you see in the plot it's coming in here. And if we look in synoptic network data, you can see we get the isoturbidity and the epiaturbidity. And here we can set up alarms. So it's possible to give alarm on erosion and sedimentation above a certain level. So that's, now that's the way to do it, reset reference levels. So it's possible to have alarms here in real time. There we have the second group, and if we go to burst samples, you see here we can look at each group by itself. And in SediMeter plot, the same thing, we can look at the groups by themselves there. And a clean time series, one for every group. Okay, so now we've seen that. Listen to network in logging mode. The advantage with this is that the data is saved both internally in the instrument and sent over cable or possibly radio and saved in the computer and even available in real time over the web if one wishes to set that up. So by having it stored in two ways, that two sites, that means that if the instrument is lost, you will not lose the data you have already downloaded. And if the cable is or communication is cut, you will still be saving data in the instrument. So there we have yet another. And then if you have a network, you can have more than one instrument connected at the same time. Here you select which one you want to see, and then you can export it here. In the synoptic network, you will see all the instruments here, one line per instrument. And that's why there are several lines over here in the reference levels. And the alarm will be set by either one of them exceeding the values. So let me now stop this and go out, and we will stop the instrument from logging. And we will check in the download. We have 40 measurements there, 41, total. That will take a little time to download, so if you have a lot of data to get down, I would recommend changing the baud rate and then download. Now it's quick. And now we have all those bursts here. So now we have looked at taking a single measurement and doing a burst measurement. Now let's look at the accelerometer. If we go to Edit, Advanced, Reconfigure Accelerometer, we see in this window that it doesn't say anything here because we have to download what's in the instrument. Get settings. Now we have the data from the instrument. So now it's set up to the default. If you click here, optional starting points, these are the defaults. Set up a SediMeter. That's what we had now. The default is 8-bit resolution, 30 samples, 10 Hz data rate, sampling time 3 seconds, and a full scale range of ± 2G with a resolution of 0.015 G per bit. And in conditions-based monitoring, because this accelerometer has two self-triggering possibilities, and one is set up to be free fall and the other to be vibration. And the free fall is, in SediMeter mode, the free fall is off, but the shake is on. But this all depends on what you have up here. So let's start with this. The resolution can also be 10 bits, then you only get 20 samples. And the data rate can be from 1 Hz to 400 Hz. And the full scale range up to 16, ± 16 G. Remember that there is always on Earth 1 G gravity. So if you have it ± 2 G, you actually have 1 G extra downwards and 3 G upwards. The other preset is SediSond mode. And in SediSond mode, we use the instrument as a penetrometer. And this only works for the SM4P model. Set up a SediMeter, edit, set settings, upload, close, and we are back where we started. And I will put it at a single measurement, and there. Now let's take a look at real-time monitoring, because this is the most convenient way to check that the instrument is working and learn how it behaves in different situations. Real-time monitoring controlled from the computer. We are not going to do bursts, because this is real-time monitoring. In this window, over here to the right, we have the synoptic network data, and here is where you put in the interval. And as a default, it's set at 1 minute. And here is when where you turn on control network as master, and you can see here the time until the next measurement. You can't change the interval while it is monitoring. So I'll turn it off, and once it's done the next measurement, I can go in here and edit it. And when it does its measurement, the data will come up here, and it will populate the tables and plots and so on. There, we got the measurement, and now we can change this again. So let's go down now and change it to 10-second interval. So we get data a little bit quicker here. More interesting. And I'll put a piece of paper in front of the sensor so we get some distinction in this graph here. There. See now. Now, they're coming in here now every 10 seconds, and we can see the bursts, samples. Oh, we have to select. We can barely hear the sound now. Now, if I want to save this data, what I need to do is put on log to file, select for each instrument on the network, because this can be done with the network. I have to select its ID here and select the file. But I have a hunch I'd better turn off the monitoring while I'm doing this, because I tried before and I got an error. So now let's do it while it's not monitoring. And we could do that for all the instruments here, but we don't have any more. Delete element. Okay. Control network as master. And log to file. I can turn it on and off with this one now. So, now let's say you want to measure quicker. How fast can we go? Well, we can go down to 1 second at least. And some special instruments that we have sped up, the maximum we've got to one customer is 20 times per second, 20 hertz, and 15 hertz with most of the sensor. Because in order to do 20 hertz, we had to turn off some. Now we have 1 hertz. But for 20 hertz, we had to turn off all the non-essential data because they were interested only in the OBS detectors. So now it's measuring and storing it to file. Turn off, just to make sure it's stored to file. We clear the memory by closing the window, reopen the window. It's gone, and we import it from the file we just created, and here it is. So that's how to do real-time monitoring. And, well, that's it, basically. Now, let me open an SM5. SM5. There. The SM5 instrument has 3 channels. This was in the pond here under ice. And we have the straight channel, we have the oblique, and we have the air and sun, and all together. And in this case, it's useful to go here to the false color, where we can select a combination of colors for them, for the 3 channels, RGB. Yeah, there we have the whole measurement. When it's blue up here, that's daylight. The sun was shining here, and still we can see, because the SM5 is much more insensitive to ambient light, because each OBS on each level is measured individually. It's not connected in parallel with the others higher up and lower down. And that's why this is insensitive to ambient light, virtually insensitive. So that also means that we can use it to measure in daylight when the sun is shining, and we can detect the water level also. We go back over here, we can see I'll turn off the temperature. We have the level, the sediment level in red, and the water level in blue. I mean, it was measured in ice and with a lot of noise around. This SM5, it has an accelerometer built in, but since so much the memory is consumed by the 3 channels, it only takes 6 accelerometer measurements, so it's not useful for SediSond measurements or for measuring vibration. It's basically intended for vibration and tilt, so you can get an idea if the instrument has fallen over. And as we can see here, when the ice melted, it did fall over, and at the end it was lying down. You can import log file here, or you can go to edit raw data. You will get to the same window. The difference is when you go this way, it will not erase what you already had in there before. So import here is the same thing as import from the other menu. Here we can see that that's a free fall. In the data plot, it looks like a few measurements, but there are actually quite a few measurements. And in each one of these, there is an accelerometer measurement here. And if we look at them as a burst group, we can see we have different events here. Let me turn off, so you only see the vertical, the Z. Here it fell, it hit the bottom, and it stayed. So this is burst group number 3. Let's have a look at that in the SediSond window. Here we have the third measurement, and in the beginning there is no acceleration because it's free falling. Here we turn on velocity now. So you see it already had some velocity from the beginning. The very first wasn't recorded. And then it stopped here gradually. And we can also turn on the OBS data from the SediMeter, the red dots here. And we can see that the turbidity increases very well together with the retardation. It doesn't go all the way down because obviously the SediMeter has a tip that's about 15 centimeters or 16, 17 centimeters below the lowest OBS detector. But this allows us to compare the turbidity of the bottom, the fluid mud of the sediment, with its strength measured by the penetrometer. So let me show you now how to set it up for SediSond measurement. First we have to connect to the instrument. And now it is in SediMeter mode. We go to Advanced, Reconfigure Accelerometer. And we have to download the settings, get the settings from the instrument. And as we see now, it is an 8 bits 10 Hz 2G. That's the standard SediMeter setting. The easy way to do here is to click Set up as SediSond, a freefall penetrometer. And this is only useful for the SM4P model, remember that. The default here is 10 bits, 20 samples, 400 Hz, the sampling time thus 0.05 seconds, which means we need 20 burst samples in a second in order to get continuous accelerometer data. And the full scale range, we set it as ±8G. If you have very soft sediments, you can put it to 4. You can get away with that, but never 2. And if you have very hard, you may want to put it in 16. The rest you can leave like it is. It's set up to trigger on freefall and not to trigger on vibration. To reprogram the instrument, you go to Edit, Set Settings, Upload. And now when we close this, you see this here value changed. This is the minimum interval between burst records. You can put it at longer, but if you do now, you will not get continuous accelerometer data. It will not be the same interval between them. And as I said, there are 20, you need 20 samples for 1 second of data. But typically you may need a few seconds more, let's say 60. We have ample margin, I think, with 60 samples. And we'll put it to start at the next time, because it will not, it's set up so that it will not start to pay attention to interrupts from the accelerometer before it has passed the start time. That's set up like that so you can go out to the boat without having a lot of data collected and the memory full on the road. The interval doesn't matter, but we just put the start time after you're out there and want to start measuring, or shortly before, preferably, like so. And then we need to set it up in CBM, conditions-based monitoring, triggered, not logged. We only want it to trigger on free fall, nothing else. Now it's set up. So now it's set up for SediSond mode. And then when we get back, we can check how it's doing here. We can check how much memory we have in data. But when we want to download, we have to put it back to sleep mode first. And I would strongly suggest to increase the baud rate. Now when you want to download, I will download to the dummy file as usual. It's quick to download. And then you can go to data and check what you got. And that's it. This wasn't data from the SediSond now, so I'm just illustrating the download. And one more thing. You are advised to erase the memory when you're using it as SediSond, so it gets a little bit easier that way. And I will do that now. This will take a while, so we'll just skip forward. All right, now we are done with that. And just to remind you that once you want to use the instrument as a SediMeter again and not a SediSond, you have to go back here to reconfigure the accelerometer. Well, you don't have to, but if you don't, you will be measuring at 400 Hertz and it will use a little bit more battery. So we can just go back like that, set it up as SediMeter. If you have it on 1 or 10 Hertz, it uses very little battery. Not much more than if it's off. And 8-bit is low power mode. 10 bits uses a little bit more. So the lowest power mode, that's where we have it set up as default. And then set settings, upload. And that's it. Now, if you want to measure continuously with a very high rate, then like burst samples with 1 second or something like that, if you do that in the way it is set up now with 10 Hertz accelerometer, you can do it. It's just that the accelerometer will be without valid data. Only the first second will be valid data, then it will be 2 seconds of zeros basically. So either you do that and you ignore the accelerometer, or you program the accelerometer at a higher frequency. I have to get settings first. So if I put it on 25 Hertz, 10 bits, and store that, and go back here, then you see I can measure at, it says 0.8, but I can measure at 1 Hertz, no problem, 10 samples. Let me do that as an illustration. And we put it at log. Now, while we're waiting for the clock, let me show you the other options here. If you put it in log and CPM, you will have measurements triggered both by the timer and by the vibration in SediMeter mode. And both of them will cause burst samples. If you only want one of them to make burst sampling, then you can select it here. Here only the timed measurements will create bursts, and the condition-based, the vibration triggered, will just take one measurement, and here's the other way around. So now let's go to logged, and we are in time, and there it took the measurement. It's taking once every second. And now it's done. So I will turn it off. Oh, let me change the baud rate back so you can see how much slower it is when we download now. Still save it to the same file. And we download the new data. This is how slow it is with 9600 baud. And we look at them. So we have a burst here, 10 data points. And in the burst samples, we have the 10 times 20 measurements. Oh, by the way, it's possible to listen to it here. So to really listen to this, we need to open a file, import a log data file that was measured with SediSond mode. I had one. All right, this is just noise, but you can hear it. There are 3 channels here. And but since there are only 2 in the loudspeakers or earphones, I made it so we can listen to either one in mono or different stereo combinations. And the purpose of this was to be able to hear pebbles and cobbles that are moving, or an anchor that's dragging over a coral reef. Here I've actually raised it 2 octaves, but this is what it really sounds like in the correct frequency. So, oh, I should mention also, if you do have more than one instrument and you want to put them up in a network, you will have to define here which instruments are in the network for real-time monitoring. In the default, the network consists of one instrument which has number 1, but here you can put in the second one, number 2. And then you would have to go to system when you're connected to that number 2 instrument and change its net address to 2 here. And now it says error, yes, because I just changed the net address of that instrument. So now, when I send that to number 1, it will not respond. But if I send it to number 2 now and ask for what mode it's in, it responds. So now I can keep working, but I need to send it to instrument number 2. So let me go back to set it to number 1, so I won't confuse the next user. But that's how it's done when you set up a network. And remember, you can change the baud rate, but when you connect The default is 9600 after reset, and the default in the connection here is 9600. So if you can't connect, you can either try changing the baud rate or reset the instrument and put it to 9600. And finally, we have the cleaning tab. The SM4, not the SM5, only the SM4 has UV LEDs that are used for measuring fluorescence, but they are also usable for anti-fouling, and that is set up here. Remember not to look at them without protective glasses on, because UV light is harmful for the eyes. Okay?